Okay, guys, so I'm going to do more of this, and I'm going to do some notes with video. I'm going to be sharing this with Miss Santos's class as well. I want to make sure you guys have the same exact notes that we have for every period, and the title of our notes today are going to be number of solutions. And when I write solutions, I want you to think of not like a solution like a liquid like you would in science, but for solutions, number of answers, the number of answers you could possibly have, okay? And we're going to do a tree map on this idea. So I'm going to actually draw my branch here. And the first part, one of these branches is going to be super simple for you to figure out. The other two might be a little challenging, but I have full confidence you guys are going to be able to get this. For this solution idea, I want you to title it for how many answers? How many answers are there? When we start doing this, let's just do one first. We'll do the one solution first. So one solution, one for one answer. All right. One solution, one. We'll put answer. Again, when it asks for solutions, it's just asking for answers. This is one answer. Okay. This one's going to be called no answer. There's no solution. Remember, it's solutions though. No answer or no solution. And this one's going to be infinite answers. And we're doing it this way to start. On the test, on the quizzes, on the state test, all that fun stuff, it's not going to be called answer, one answer, no answer, infinite answer. It's going to be called solutions. So we'll talk about that too. We'll make sure that's clear when we do take our quizzes or whatnot. When you see what does infinite solutions mean, it just means infinite answers. This means every answer works. It's kind of confusing. This means there's only one answer that'll work. And this means that there's no answer that'll work. And what are we talking about? We're specifically just talking about equations. What you guys have been doing for the last 3 weeks, basically, is what we're dealing with. So when we talk about equations, let's go ahead and actually start solving an equation. When I give you, let's just say I give you a problem here, all right? And it may be a little more intense, and you guys are totally fine with that. So 3x plus 4, all right, write this down, equals 5 times x minus 2. All right, go ahead and write that down. And I would love if you guys could. This is the quiz on you guys. Can you guys actually get to a point and solve this? All right. So go ahead and go for it. Try to solve this. And if we're going through this, I would love to see some good work. I want to see the work written out. So when you're starting this off, right? And you're also doing this here, okay? So you're going to get 6x plus 8 equals 5x minus 10. Okay, now the next step, I'm going to do it in a different color so you can see. The next step would be to go ahead and move over your variables. Remember, we want all our variables on one side and all of our constants on the other. We're going to subtract 5x to both sides. When we do this, let's be very careful here. When we do this side here, we're just going to put that there to kind of cancel it out, right? Over here, it's going to become, and I like it when it's 6x and 5x, you're going to say it's 1x or just x, the same thing, right? Plus 8 equals, bring this down, negative 10. Okay? As I keep going, I'm going to use a different color now. And I'm going to go ahead and subtract 8 to both sides. All right, that comes down. Now I have 1x equals, this is the interesting part, negative 10 and negative 8. You can always plug it into a calculator, but some people are still struggling with the idea that, just imagine you owe somebody $10. Doesn't that mean like negative 10? All right, you owe somebody $10 and you owe somebody else $8. So when you owe these two together, when you have two negatives together, negative 18. If this was a negative 1, you would have to divide it. But isn't this the same as this as well? Do we really have to write this invisible 1? I always joke saying they should always keep it 1x. I think that's important for you to see that. But in the math book on the test, they're going to look like this, okay? X equals negative 18. So this is what we're talking about. Did you get to a final answer? What does x equal? X equals negative 18, right? So this answer here, there's only one answer. What's the one answer? X equals negative 18. And you're going to see that whenever you get something, everything we've been doing for the last 3 weeks has been one solution, one answer. Okay? So now we're going to move on to something that looks a little different. Okay? So don't worry. Don't worry. We're going to get through this. I just want to keep this on the side here so you can see this. And I do want to separate my work a little bit. So I am going to go ahead and take one of these lines and just kind of draw a separation line so we know the work here. All right. And then give me 1 second here. All right. Sorry about that. And then, all right. So, back to the screen here. Now, let's go ahead and, for some reason, my camera decided to go off there. Let's go ahead and dive back into this concept. There's one answer here. This one says no answer, and I really want you to see what it looks like. I'm going to go ahead and go. All right, there's my problem. You have an equation, you look at it, you can see what exactly, like from here, you know what to do first. You want to get rid of your parentheses, first step. So go ahead and do that. I wouldn't say go ahead and try to solve it all the way through because I want to take you step by step. So don't just try to go through and solve it like you normally would because it's going to be a little different. So here, you're going to go 4 times x, 4 times 3. Then you're going to have 4x plus 15. All right. Now I want you to take a second here. You just did the distributive property. That's great. Here, when you're looking at these two variables and constants, they're all different. When you look at this, you notice, interesting, I have the same variables on both sides. That's going to be interesting. That's going to be a little different on what's going to happen. So let me show you. From here, let me go ahead and draw my separation bar. I always need this bar in your mind. We're always taking things from one side to the next, okay? Just like here, we're going back and forth. So our next step is always to go letters to the left, right? We're going to bring our letters to the left. So to do that, let me go ahead and get a better mark. Here we go. When I do this, I'm going to go subtract 4x to both sides. And like, remember here where I said just put a 0 and cancel it out? You move that over, right? But what happens over here? What's 4 minus 4? Interesting. This is when you know, whenever you get to this, that was fine. The 1x is fine. The 0x is not. Your brain at this point should be triggered that something's wrong, something's different. Not wrong, but something's different, okay? And bring down the 12, bring down the 15. All right? Now, from there, let's keep going. Let's make sure we keep going with our skills that we know. We know now we're going to move over this 12, move over the constant, correct? Move the constant to the right. That cancels out. I'm going to bring this down. 0x equals 15 minus 12 is 3. And that is your final answer, okay? But this is where we have to start thinking. If we have x equals negative 18, that's our answer. If we plug in negative 18 in here, it's going to work. So here's the deal, though. this is 1 times a number, right? 1 times a number. If I wrote that out, 1 times, right? 1 times negative 18. Right there, 1 times x, 1 times negative 18 equals negative 18. Here is telling me 0 times a number. 0 times a number. What times 0? You're only going to get one answer here, right? Anything times 0 should equal 0, not 3. What number could I put there? If I put 3 there, 0 times 3 doesn't equal 3. Nothing, nothing. There's no answer. Ooh, here we go. No answer. Anything times 0 should equal 0, correct? Anything times 0 should equal 0. So how are you going to get 0x equals 3? There's nothing that works. So this answer is considered no solution. I want you to write down the bottom. No solution. Whenever you get a 0x equals a number, it's no solution. Whenever you get a 0x equals anything, any number, it's no solution, okay? Now, let's go ahead and get over here to this side. We're almost done with our notes. This is one solution. Why don't you go ahead and write that down? And then let me separate this over here to make sure we're clean. And we're going to write these out. These notes are super important for you to keep, to use again. I hate having notes that you never look at again. There's no point to writing notes if you're not going to look back at them. Now, here's our last level. Now, this one's infinite answers, okay? That's crazy. Every answer is going to work for this one, which seems kind of crazy. But let me just go ahead and keep this idea going. I'm going to use something very similar we just did. All right. Why don't you go ahead and do the first step like we've been doing? Okay. When I look at this, I'm looking at this. Look at both these sides. Before, we noticed over here, when we were looking at this, we noticed that the 4's were the same, the 4x and the 4x, but the constants were not the same. Same variables, different constants. All right, same variables, different constants. Over here, we have the same variables and the same constants. Notice that? Same variables, same constants. Interesting. Okay, let's keep going. So from here, we're going to go ahead and we're going to go subtract 4x to both sides, right? That's the next step. I'm going to get 0x plus 12 equals 12. All right. Then from here, I'm going to go ahead and subtract 12. Zero x equals 0. Interesting. Now that's a little different than what we had before. Before we had 0x equals 3, or a number. Now here's the idea. What if you said x was 2? What if you said x was 2 and you plugged in 2? What's 2 times 0? 0. What if you said x was 4? Let's just say x is 4, okay? What is 4 times 0? If x is 4, we're going to plug it in, right? 4 times 0 is 0. What if I said x was a million? X is a million. You plug it in, times 0 equals 0. So the idea here is that every single answer works. Every single one. Anything you want to choose for x is going to work. So when you get to 0x equals 0, it's infinite. And you're going to have different ways that they're going to show this. They might write infinitely. Let me make sure I write this right. Infinitely many solutions. I think I wrote infinite wrong there. Infinitely many solutions. Infinitely many solutions. And what I like to put a poster on the wall, my poster is going to look like this. So it'll be 0x equals 0. And this is you guys know the infinity sign? It's like the number 8 laying down. This is what I like to do. When I see 00, I almost like to make the infinity sign around the zeros. And that's what it is. It's infinitely many solutions. Every solution is going to work. All right. So let's look back at our notes again real quick. When you get x all by itself, not 0x, these are both 0x's. 0x's are weird. It's either going to be no solution or infinite solutions. But when you get the 1x, it's always going to be one solution. X is just one solution. 0x could be either one. We got to figure out which ones are which. Okay, guys? Great job.